Today's lesson is going to be on how to interpret PT, position time graphs. I guess we should firstly ask, what is a PT graph? Well, a position time graph is just a visual representation of motion, which is a very important concept in physics, a concept which is tied into kinematics. Now, for this discussion on motion and PT graphs, I'm going to introduce you to my trusty friend Pat. That is a RoboDog. And why we're using a RoboDog, well, maybe it'll become obvious later on. It relates to the type of motion that Pat has been asked to do in this graph. While looking for a little photo of a RoboDog, I noticed online that this RoboDog costs about $2,500 to purchase. Wow, what is the world coming to? Anyway, a position time graph is a way to represent motion, and we can see from this position time graph, this specific position time graph, that we've got position plotted against time, and we've also noticed that we're noticing different types of motion at different points in the position time graph. Okay, so what we're going to notice is what we'll do is break down the different time values and what's happening at those positions. Okay, so firstly we're going to look at 0 to 10 seconds. We'll notice that Pat is moving away from this 0 point. Now this 0 point is what's referred to as the origin. Pat is moving in a positive direction. That could be north, it could be left, it could be right, or it could simply be positive in your examples. It just depends on the example and what's happening. So for this, let's say we're talking about the positive direction, and Pat is actually moving in that positive direction. Okay, so Pat is going to be moving along the line, and we can see that Pat has moved 60 meters in 10 seconds. Okay, so if we represented this, Pat would be moving up to a point which is 60 meters away from the origin in the positive. Now we'll also notice that this slope is a straight line slope, and it means that each one of these, for each second, Pat moved the same amount of distance. So for example, between 0 and 5 seconds, Pat moved 30 meters, and between 5 and 10, Pat moved another 30. So we see that the slope is not changing. Remember that slope is equal to rise over run. And in this instance, if we look at simply the units of that, it would be meters over seconds. So meters over seconds. And we know, and we will talk about how distance over time, meters per second, is equal to velocity. So in PT graphs, slope is equal to velocity, and that's a very important point first off. Can we calculate the slope for the yellow section, the first section that we've just looked at? Sure we can. We just take our value, we take our y value, y2 minus y1, which is 60 minus 0 meters. We put it over our x value, x2 minus x1, and we get 6 meters per second. So from a PT graph, we can see various different things. And one of the things that we can see is the slope. And the slope will tell us the velocity of the object, in this case, Pat. We can also see certain things like between 10 and 15 seconds, Pat is not actually moving up or down on the y-axis. So Pat is not moving with reference to the origin. So Pat is stationary. In the third section that we're going to look at, we're going to show it with the color green. Sure, why not green? It is Pat after all. We're going to see that Pat is moving now with a negative slope in the green section. And of course, we can calculate that negative slope. We would just simply take the negative 40, take away negative 60, which would give us 100. I'll just show that actually. Negative 40, take away 60, all over the number of seconds, which is 40, minus 15. And that gives us negative 100 meters over 25 seconds, which is equal to negative 4 meters per second. So we can see a couple of things here. The slopes, calculation of the slopes would tell us that the first part, where there's movement, that velocity is higher than the second part. Also, it tells us in the first part, the velocity is in the positive direction, and in the second part, it's in the negative direction. In other words, this object, in this case, Pat, the robo-dog, is moving in the opposite direction for the third part as it is to the first part. And of course, we could continue that on, and we could look at maybe the third part, and we could calculate the slope for the third part and find out what's happening there. Okay, PT graphs also allow us to ask different questions. So another way to interpret it and different questions you might be asked is, for example, during which stage or stages is the object moving south? So whatever the object is, which stage is it moving south? Now you can see that in this case, the positive direction is north, the negative is south. It doesn't need to be like that. The positive could be south and the negative could be north, but we've been told that north is on this side of the y-axis, so therefore it is north and the opposite is south. So the object, which part is it actually moving towards the south direction? Well, we can see that the object is not moving in A to B. The object appears to be moving back towards the origin with a positive slope in B to C. Object is not moving C to D. An object again has a positive slope, so is moving in the positive direction in D to E. Object not moving E to F, stationary, velocity of 0. So the only part of this graph that the object is moving south is F to G. And of course, you can calculate the velocity of that, how quickly it's moving, by looking at the slope and getting the values for the slope. Another question that might be asked is, what is the velocity between 5 and 11 seconds? So between here, 5 and 11 seconds. Similar scenario to the last time. If we want to calculate that, we get the y2 minus y1, and we put that over x2 minus x1. So let's just do that as an example. y2 minus y1. So in this case, it would be negative 2 y2 minus y1. So negative 2 minus negative 5. All over the seconds, which would be 11 minus 5 seconds. So this gives us 3 over 6 meters per second, or 0.5 meters per second. We can see that it's not moving as quick as the objects in the last graph. We can also see that it's moving with a positive, therefore it's moving in the positive direction, or the north direction. Okay, so we can see the PT graphs can tell us quite a bit. The slope is related to the velocity of an object, and the actual the sign will tell us what direction that object is moving and what velocity it's moving with. Now, the RoboDog was perfect for the last couple of graphs because we were seeing velocities that did not change. When we looked at it, we saw something like this. And when we saw these velocities, they were going up in nice straight lines like that. And we saw that the slopes between here and here were straight. In other words, in this section, the velocity was not changing. So it appeared between A and B that RoboDog was able to change from 0 velocity right away to a negative velocity, let's say negative 10 meters per second. Kind of weird, only a RoboDog might do it. The dog pictured here would not. A normal dog would not act like that. It would act like a lot of objects, which means it would speed up and slow down. So how would you show that on a PT graph? Well, PT graphs will also have curves. What does a curve mean? A curve on a PT graph is tied into acceleration. To show why, we're going to look at 2 points on this PT graph shown with the yellow the yellow lines and denoted as section A and B. So in section A you can see, and section B you can see that I've drawn a tangent to the curve. Now a tangent is a straight line that touches a curve at one point, only one point. And what a tangent allows us to do on a PT graph, a tangent allows us to look at the velocity, the slope at a particular point in time. So if we work our tangent down where it touches the curve, we'll see that for this seconds here, we can get the exact velocity. Likewise, if we work our tangent down to the seconds, B is between 4 and 5 seconds, we can get the instantaneous or the velocity at that very moment. You can see that the velocity, the slope velocity, is greater at interval B than it is at interval A. So that means there's a changing velocity, and a changing velocity means that there's actually acceleration in play. The velocity is not the same, velocity is getting greater, or it might be getting less depending on how the curve looks. But when you have curves in a PT, a position time graph, it means that acceleration is in play. Okay, so let's look at a more complicated PT graph. On this PT graph, we're showing that the positive is east and the negative is west in the opposite direction. And I'm just going to go through 3 sections of the graph, A, B, and C, where there's different types of motion happening. Okay, so if we look at part A, we can see that it's very straightforward. It appears in interval A that the object is moving east. It's moving away from the origin in the positive direction, so it's moving east with a constant velocity. We do not see a curve, and of course you would be able to calculate that if we put some figures in, if this graph was a little bit more detailed. In part B we can see that the object appears to have a slope which is changing, and if we look at the beginning of this, the slope appears to be greater than the slope at the end of this. So what does that mean? Well, it's tempting to say that it's decelerating, sure, but it's more correct in physics to say that the object is moving with a negative acceleration. And we'll just show acceleration as an A with an arrow over it. And we'll come back to what that means later on. But a negative acceleration means that the velocity is getting smaller. We could also choose to say that it's moving with an acceleration in the west direction. In part C, we can see that the object appears to be now accelerating towards the west. And if we look at this in part C, we'll see again, if we look at and we take the slopes at various points, we can see that the slope at the end of interval C has a much higher magnitude. And yes, it is a negative, but it's got a higher magnitude. So it appears to be getting greater in the negative. So the object is moving with, again, a negative acceleration, or an acceleration in the westerly direction. Okay, so that's just breaking down 3 intervals on a PT graph. You can have a look at sections A. We've done A, B, C, and you can look at D, E, F, and I'll ask you some questions based on that, and we'll take those questions up in the next lesson.